In this video, we are going to find the probabilities in a binomial experiment. A grocery store gives away scratch-off cards with a purchase of $100 or of more than $100. Terrell has 5 scratch-off cards. What is the probability that he has exactly 3 winning cards if each card has a 30% chance of being a winner? So looking at this formula was given at the beginning of this section, and I said we weren't really going to use this until the end. So we're at the end of the section, and this is the formula that we're going to use. We use this formula for a binomial probability. So if we have a binomial experiment, we use this formula. NCR, that stands for combinations, and we've seen that before. The new variable that we haven't seen before is P. And P is the percentage of success. So whether you want to win or lose on one of these scratch-off cards, winning would be the success. That's what we would want. And then failure would be losing if we scratched off the card and we lost. So P is the percent of success, and then 1 minus P is the percent of failure given a binomial experiment. So let's figure out what the probability is that Terrell has of winning exactly 3 cards. So we have the probability of 3 is equal to, we have a total of 5 cards, and then we're going to combine those in any given way. So we're not going to use permutation because order doesn't matter here. We just want any of those 3 cards to hopefully be winners. So we're going to have 5 combination 3, and then times, we have a 30% chance of winning or of being a winner. So that's going to be 0.3 raised to the 3rd, because we're hoping for 3 winning cards. And then to get 1 minus P, we're going to take 1 minus 0.3. That is going to be, well, we'll just write down 1 minus 0.3 for now. And then it's raised to the remaining cards. So if there's 5 total cards, you're subtracting out 3 winners. There's 2 that are failures. All right, so then we have 5 combinations 3.3 to the 3rd. 1 minus 0.3, that's 0.7 squared. And then all of this we can enter into our calculators. You know how to enter in combinations. You know how to enter in a number raised to an exponent. So once we simplify all of that down, we get 0.1323. And multiplying that by 100, we can change that to a percent of 13.23% chance of winning. So Terrell has 13.23% chance of having 3 winning cards. So now let's go through another example using the same formula. So you may want to write this formula down. We're going to use the same formula in the next example. Terrell still has 5 scratch-off cards, each with a 30% chance of being a winner. To the nearest 10th of a percent, what is the probability that Terrell has more than 3 winning cards? So we have probability more than 3. Well, if he has 5 cards, what this really means is, what is the probability of the fact that he has 4 winning cards or 5 winning cards? Remember, if we have a probability with an or, we add those probabilities. So we're going to have probability of 4 or probability of 5. So probability of 4 is equal to, we want any 4 of those 5 to be winners. So we have 5, then combination 4. We want 0.3 to be raised to the 4th because we're hoping we have 4 winners. And then 0.7 raised to the 1st. If there's 4 winners, then there's only going to be 1 losing card. And then we also have probability of 5. So what's the probability that he has all 5 winning cards? So we have 5, combination, 5, 0.3 to the 5th. Well, if all of them are winning cards, then there's none that are losing cards. So we're going to have 0.7 raised to the 0 power. And then both of those, we can simplify those down using our calculators. So we get 0.02835 plus 0.00 0.00243. Adding those two together, we have 0.03078 equals, and then multiply 100 to change that to a percent. We have 3.078%, although they wanted us to round it to the nearest tenth. So he has a 3% chance, a 3.1% chance of having more than 3 winning cards. So not too high of a chance, but 3% chance of winning cards is still pretty good. So now you can try finding binomial probabilities on your own.